What's up, fam? This is your math teacher slash baseball coach, Coach Knight. Hoping everyone is doing well. I'm going to do this little video to take you through the basics of graphing sine and cosine functions. Yes, we have to graph them on a XY coordinate plane, basically, is what's happening here. Just real quick, before we get started, here's our circle. Everybody knows about the circle. It starts at 0 degrees or 0 radians, either one, and it goes up to 90 degrees or pi over 2 radians, depending on which one you're working with. You have 180 degrees there, or just pi radians. Here you would have 270 degrees, or 3 pi over 2 radians. And then finally all the way back around would be 2 pi or 360 degrees. And so that is basically what's happening here. And the graph, if you notice, when you do the circle, when you go around the circle, and you just keep going around over and over and over again, you'll get the same values. So we call this a periodic function. And basically all of the definition of a periodic function is you basically keep getting the same thing repeating itself over and over and over and over again. You see this in waves. When I say waves, I mean like frequencies of radio stations. They have sound waves that go in waves, kind of like sine and cosine, and basically you also see this on drawbridges a lot of times. In fact, many times the frequency of a bridge, if any of your family is in the military, and they're marching, the military break their cadence when they cross a bridge. And the reason for that is because a long time ago, an army regiment actually crossed a bridge and made it fall because their cadence happened to be in line with the natural wavelength of the bridge. You can kind of look that up. You can Google that, but that's true. And so from now on, whenever an army group come to a bridge, they all break stride rather than all going at the same cadence. So anyway, that's your history lesson for your math class today. Getting back to work. As I said, both sine and cosine, the graph looks the same. They are just different places on the XY table, okay, or on the XY chart. So here's my X axis, here's my Y axis, and basically we're going to start with sine of X. And for sine of X, I have the table down here, and you can basically just see and understand all this table is and all this graph is they have taken this circle up here and basically cut it and rolled it out into a straight line. So right now, here's 0, and here's pi over 2, or like we talked about, that's 90 degrees. Here's pi, 180 degrees. 3 pi over 2 is 270 degrees, and 2 pi is 360 degrees. Most of the time when you're graphing them, though, you will use radians simply because the numbers are smaller. Okay, when you're talking about pi, that's 3.1415, blah, keeps on going forever. That's a lot smaller than having to do 180 degrees. So most of the time when you are graphing, they will be in radians. So just prepare yourself for that. Basically, if you take, I start here at the beginning, if you take the sine of negative 2 pi, you will get 0. And so there you make a point there. All right. I'm going to skip the negative 7 pi over 4 one and just go to the negative 3 pi over 2, which again is negative 270 degrees. You get 1. And then at pi, or at negative pi, I should say, you're back at 0. And at negative pi over 2, you're down at negative 1. And then at 0, you're at 0. At pi over 2, you're back up at positive 1. At at pi, you're at 0. At 3 pi over 2, you are down here at negative 1. And at 2 pi, you are back at 0. So here is your graph for the sine function. That's terrible. I'm going to try that again. If I can erase it. Here we go. Let me try drawing that a little better. It does take a little time to draw it all nice and smooth. But that is your sine graph. And that keeps going forever and ever until you want it to stop. Let's talk some characteristics of it. If you'll notice, sine crosses the x-axis at the pi's. And when I say pi's, basically I'm talking about at negative 2 pi it crosses at 0 at the x-axis. At negative pi it crosses at the x-axis. At 0 pi it crosses at the x-axis. At 1 pi it crosses at the x-axis. And at 2 pi it crosses at the x-axis. And that's a characteristic of the sine graph. Also, if you know, notice at the half pi's, it's always either a maximum or it is a minimum. So here at negative 3 pi over 2, you go up all the way to positive 1. I don't like that color. Let's make it a little darker. There we go. And then at negative pi over 2, we go down to negative 1. At positive pi over 2, we're back up to positive 1. At 3 pi over 2, we're down at negative 1. And that also continues in a pattern. It just keeps going forever and ever. And so what you can do is I have basically, to make it easier to graph, I don't ever actually make points for these that are in the middle here. I just stick to the pi's and the half pi's basically. Now that will change when we get a little more complicated graphs, but for right now we're just doing the basic sine and the basic cosine graphs. So if you notice, after an even pi, you go up to a maximum. And notice the maximum is 1, the minimum is negative 1. And that's always the case when you're just talking about sine x. Now, of course, that can change when we change the equation. But for right now, for today, we're just doing the basic sine and cosine graph. So after the even pi's, you'll always be going up to a maximum. After an odd pi, you will be going down to a minimum. And that happens every single time. 0 pi would be even when you go up to a maximum. Here is an odd pi, and after it, you'll go down to a minimum. And basically what I do is I take one period worth, and a period is simply one complete wavelength of your graph. So, for example, I'm going to highlight it. One complete wavelength would be down, boom, one complete wavelength. Now, what is that just there? What did we just do there? We did a complete circle. That's one full wavelength. Okay, so my period, they call it a period. My period for this graph is 2 pi. And again, period is the time it takes you to go from one point on your wavelength all the way back around, and you do a complete wavelength. Okay, so it took us from 0 and we got done at 2 pi. Okay, or you can start at pi. If you wanted to do a different color here, we could start at pi and it goes down all the way negative pi to pi, which again is 2 pi. So again, in conclusion, a period is simply one full wavelength of the equation. I have here 2 full wavelengths. I have one wavelength here, and then I kept going, starting at 0, and did another wavelength. So this is 2 periods worth of the graph. The other thing that you might want to understand is amplitude. Now the amplitude is simply how high or how low it goes from the midline. Now the midline, you guessed it, is the line that goes in the middle. So how high did we go above the midline? In this case, we went up 1 and we went down 1. So the amplitude is 1. Now understand, amplitude is measuring distance. So distance is always positive. No matter if it's going up or down, we always call it a positive number. In the equation, it could be negative or positive. But like I said, for today, it'll all be positive. So understand, this is the equation right here. Y equals A times the sine of X, where A is your amplitude. And like I said, our amplitude was 1 right there. There's an understood 1 in front of that sine of X. So that means it's going to go up 1 and down 1. Okay? So again, this was sine. This was the sine graph. All right? So when we change it up to do the cosine graph, everything is pretty much the same. It's just been shifted over. For your sine, remember we crossed the x-axis at the pi's, so negative 2 pi, negative pi, 0 pi, 1 pi, and 2 pi. We're always crossing the x-axis. It's opposite on the cosine. On the cosine, your x-intercepts are at the half pi's, so negative 3 pi over 2, negative pi over 2, positive pi over 2, and positive 3 pi over 2. There's where you're crossing your x-axis. Your y-axis, again, goes from 1 to negative 1. That is the amplitude, 1. And your period is still 2 pi. So, x can be anything you want it to be on sine and cosine, but the y will always be between 1 and negative 1 if you're dealing, again, with just sine and cosine. Now, if you throw other numbers in there in the equation, that will change your period and it could change your amplitude. But for today, like I said, we're just doing basic. So, back to my cosine. Here, on the sine, you noticed we had maximums at the pi and minimums at the pi over 2's. So it was a maximum if it came after an even pi over 2, and it was a minimum if it came after an odd pi over 2. So what am I talking about? I'm talking about here, negative 2 pi, that is even. So guess what comes after it? A maximum. Okay? This one, negative pi, it's odd. Negative 1, 1 is odd. So what comes after it? A minimum. And if you can remember that, cosines are very similar. Only when we don't put what they come after, we put what they are. So here, this is an even pi. Negative 2 is even. So it will be a maximum. It will be up at 1. Negative pi, and that's negative 1 pi, it's odd. Odd. So it will be at negative 1. 0 pi, it's even. So it's a positive 1. 1 pi is odd. So it will be down here negative. Sorry, the 0 was even. 1 pi is odd. 2 pi is even. So it will be back up at positive 1. And again, it's the same graph. It's basically just been shifted over 90 degrees. Okay? So, same graph. It's just been shifted over to the right 90 degrees is basically what's happened. Or to the left 90 degrees, I should say. So, the top one here is the sine of x. Notice where it crosses. The bottom one is the cosine of x. Notice where it crosses. And the way I do it is I always just break my one period, again, period down here will also be 2 pi. And again, if you took it from here, one full wavelength is 2 pi length. Okay? It takes 2 pi to go 1 full wavelength. And if you notice, what I've done is I've broken that wavelength into 4 parts. Here's one, here's one, here's one, here's one. I always do that. I always cut it into fourths, and then it's very simple to do. You're going to graph your maximums, your minimums, and where it crosses the x-axis, and then just draw your wavelength. Okay? So here's a couple of examples. I've got 4 on here. We'll see how much time we've got. I've also put an interval that we're going to graph it in. So if you notice, this one, they don't want the whole graph. They just want the graph from 3 pi to 5 pi. So what I'm going to do is I'm going to draw my equation or my line here. That's a terrible line, but we'll work with it. That's my y-axis. Here's my x-axis. And now, rather than graph a whole bunch in between, I'm going to make a little break symbol, which looks kind of like I don't know, a lightning bolt, something like that. And all that means is you're skipping a few, okay? And basically what I'm going to do is I'm going to graph. I'm going to let this first one be 3 pi, and I'm going to go all the way to 5 pi, and I'm going to divide that into fourths. Notice, what's my period here? How far is 3 pi away from 5 pi? It's 2 pi away. So we're going 1 full period here. So I said have 1, 2, 3, 4. So 3 pi to 5 pi. That's my interval that I'm graphing here. Okay. So halfway in between 3 pi and 5 pi would be 4 pi. And then a lot of times you have trouble labeling this interval and this interval, and it's pretty simple. Basically, you take this pi, 3 pi, and you add it to 4 pi, and that's 7 pi, and then you divide that by 2. So this would be 7 pi over 2. Same thing on the other side. 4 pi plus 5 pi is 9 pi, and again, you just divide that by 2. That would be 9 pi over 2. Now, here's how we're getting that. 3 pi is actually 6 pi over 2. 4 pi is actually 8 pi over 2. And 5 pi is actually 10 pi over 2. So, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2. If you notice, we're just going by pi over 2s every time. Okay? So, I'm going to erase those so we don't get confused. And now we're going to follow our rules. Again, we already know what the graph looks like. We just got to know where to start. Where does it cross the x-axis? And where does it cross the y-axis? Or where are my maximum and minimums, I should say. So, we're talking about sine. So if you remember, sine crosses the x-axis at the pi's. So, I'm going to pick me out a blue color here. So it's going to be crossing the x-axis at 3 pi, and at 4 pi, and at 5 pi. All right, and then what was the rules that we used to know whether it's a max or min? So remember, after 3 pi would be odd. So after an odd pi, it's always a minimum. It's always down here. I should have said this was labeled, this is 1 and this is -1. That's how far up and down we go. So it's a minimum after an odd pi. 4 pi is an even. So it'll be, after an even, it is a maximum. So up here is a maximum. And basically, now you just connect the dots. So you just draw you a nice, as smooth as you can, little wavelength. Again, that's terrible. We'll try again. Here we go. There we go. That's better. All right. Same thing. Here we are. We still have y equals sine of x. So it's the same equation, just with a different interval this time. This time we're going from -17 pi over 2 to -13 pi over 2. So Notice we're in the negative, so I'm going to actually draw my wavelength the other direction this time. Again, the highest it would be is going to be 1, and the lowest it would be -1. And we just label our parts here. Again, I'm going to do a little break. So this first one is -13 pi over 2. And we're going all the way to -17 pi over 2. All right. And I realized something. I labeled that incorrect because -13 pi over 2. Oh, no, I didn't. Yeah, I did. -13 pi over 2 would be, well, let's see here. Nope, we're good. I'm sorry. All right, so what would be halfway between -17 pi over 2 and -13 pi over 2? That would be -15 pi over 2. And again, I know we're dealing with fractions, but they're easy fractions. It's not that bad. So, what would come in between -13 pi over 2 and -15 pi over 2? Well, that would be -14 pi over 2, which is -7 pi. And then same thing here. What comes between -16 pi or -17 pi over 2 and -15 pi over 2? That would be -16 pi over 2, which reduces to -8 pi. And so now we have our intervals, and now we just play the game. Again, we're at sine, so I know I'm crossing the x-axis at the pi's. So 8 pi and 7 pi, -8 pi and -7 pi will be my x-intercepts. And remember, we talked about it. After an even pi, it will be a maximum. So here's -8 pi is even. -7 pi is odd. So after the -8 pi, to the right, when I say after, we're always moving from left to right. -8 pi, so after that would be a maximum. And then after the odd would be a minimum. And then we have one more over here that we needed to do. If we go to the left, well, that means that one must have been down below it, because if the one to the right of it is a maximum, the one to the left of -8 pi has to be a minimum. And then we draw our graph. It just kind of looks like a big hill here. Hopefully your graphs will look better than mine. So those are 2 examples of sine. Here's 2 examples, 3 and 4, of cosine. So we're doing the same thing. Same exact thing here. So we got we have the y and the x-axis. We're going +1 down to -1. That's our range. That's it. That'll have to come in between those. We'll do our little break. And right here, we're going from 9 pi over 2 all the way to 13 pi over 2. And again, if you hadn't noticed, our period, they're 2 pi away. It's 1 period worth. So we're doing 1 full wavelength. After 9 pi over 2, or between 9 pi over 2 and 13 pi over 2, halfway would be 11 pi over 2. And then in between 9 pi and 11 pi would be 10 pi over 2, which is 5 pi. And if I'm saying that kind of quick, 10 pi over 2 reduces to 5 pi. That's what's happening there, okay? Here, 11 pi and 13 pi. What comes between 11 pi and 13 pi? Well, that's 12 pi over 2, which reduces to 6 pi. So, and again, remember, we're talking about radians here. So 6 pi is actually, when you think about it, it's actually going around the circle 3 times. Because going around it once would be 2 pi radians, twice would be 4 pi radians, 6 pi radians would be 3 times around the circle. Cosine, remember, things are different with cosine. You don't cross the x-axis at the pi's, you cross them at the half pi's. So we're going to have a x-intercept at 9 pi over 2, 11 pi over 2, and 13 pi over 2. Those are the I like to call them the half pies. And then we'll have a maximum and a minimum at the pies that are whole, they're whole numbers. So 5 pi, well, I should say integers because they can be negative. 5 pi is odd, and we've already talked about it. If it's odd, it's going to be a minimum. And 6 pi is even, so it will be a maximum. And you draw your graph there. Okay? Last example of the day. Again, here we're going from negative 6 pi to negative 4 pi. We're still doing cosine, so we're just going to go again back the opposite direction. My range is from 1 to negative 1. This is my y. My x goes in this direction. All right, so we're going to make our break. And again, all that means is we're skipping a bunch, and then we're starting at negative 4 pi, and we're going to end at negative 6 pi. And again, if you notice, I've done this every time. You make 1, 2, 3, 4 intervals. It's very, very simple. So what comes halfway between 6 pi or negative 6 pi and negative 4 pi? That would be negative 5 pi. And again, to get the middle ones, it's pretty simple. Negative 5 pi and negative 4 pi make negative 9 pi over 2. And then negative 6 pi and negative 5 pi make negative 11 pi over 2. Those would be your intervals there. And then you graph it. So I'm going to cross the x-axis at the half pies, which would be there and there. At negative 6 pi, that's an even, so I'll be up here at a maximum. At negative 5, that's an odd, so I'll be down here at a minimum. And then negative 4 pi, again, is even, so I'll be up here at a positive. And so here we go. Play connect the dots, and you're done. That's one full wavelength. Again, very, very simple equations. We'll get to more complicated ones on the next video, but this one is the basic how to graph sine and cosine. Again, real quick, sine crosses at the pies. Cosine crosses at the pi over 2's. Crosses the x. When I say cross, it crosses the x-axis at the pi over 2's. Sine crosses the x-axis at the pies, the integer pies. For your sine, after an even number is a maximum. After an odd number is a minimum. Now for cosine, on an odd number is a minimum, and on an even number is a maximum. And again, that happens every time. The graph is going to look the same. It's just a matter of where you're putting the intervals. So hope this helps. Y'all have a great day.